Hey everybody. Today we're using R to do some computations in the hypergeometric distribution. Remember, the hypergeometric distribution models the number of black chips drawn from a bag that includes both black and white chips when n chips are drawn at random. This is distinguished from the binomial distributions in that these draws are done without replacement. When you're computing in the hypergeometric distributions in R, there are four basic functions you want to know. The first is rhyper, and this is going to generate k random values from a hypergeometric distribution where you have n1 black chips, n2 white chips, and a sample size of n chips drawn from that bag. For instance, rhyper 10, 12, 6, 4 generates 10 different values, each of which representing the number of black chips drawn when a draw of size 4 is done from a bag with 12 black chips and 6 white chips. Next is the dhyper command, which is going to return the probability of drawing x black chips from that same bag, n1 black and n2 white chips, and a total sample size of little n. As usual with commands in R, x can be a vector here. For instance, dhyper 0:4, 12, 6, 4 gives you back the probability of getting exactly 0, 1, 2, 3, and 4 black chips from that same bag that we described before. Next, phyper. This is a cumulative probability distribution function. It gives you the probability of drawing at most x black chips from that same bag. Once again, x can be a vector here. For instance, phyper 0:4, 12, 6, 4 gives you the probability of getting at most 0, 1, 2, 3, and 4 black chips from that same bag as before. Finally, qhyper is the inverse cumulative distribution function for the hypergeometric distribution. To say it differently, it returns the smallest x value such that phyper x, n1, n2, n is greater than or equal to the p that you fed it inside of the qhyper command. Another way of saying this is that qhyper is computing quantiles in a hypergeometric distribution. For instance, qhyper of 0.4068627, 1264 is 2 because phyper of 2, 1264 is 0.4068627. All right, let's do a few actual problems. Each of these examples is going to deal with the same situation. A statistics class includes 19 women and 11 men. A team of 5 people is to be selected at random. First of all, what's the probability that this team, when randomly selected, includes at most 3 women? That it includes at least 3 women? All right, let's swap over to R here. I've started by pulling up the help file for the hypergeometric distributions using $dhyper. Let's jump right in and compute some probabilities. So, first we want the probability of at most 3 women. This is a cumulative probability function. So we want phyper, then the value that we're interested in, 3, the number of women in the sample, the number of men, and then the sample size. So in this case, it's about 0.62. So that's the probability of getting at most 3 women. Next, the probability of getting at least 3 women. So the important thing to recognize here is that the event where we get at least 3 women in our sample is complementary to the event when we have at most 2 women in the sample. So let's do 1 minus the probability of getting at most 2. So that's going to be the same phyper command that we did a second ago, but now with 2 first. So in this case, about 75%. Problem 2. Construct a probability histogram for this experiment. Okay, so we have 6 possible outcomes, 0, 1, 2, 3, 4, and 5. We're going to want to plot those values on our x-axis, and then we're going to want to put probabilities for each of those, again, from the hypergeometric distribution, on our vertical axis. So let's start by encoding a vector consisting of our possible outcomes, 0 to 5. And now let's get a vector of probabilities. So in each case, we want to get a probability in the hypergeometric distribution. The probability of getting X women when we select from a population with 19 women, 11 men, and a sample size of 5. So let's see what that looks like really quickly here. So there's our vector of probabilities. In order to make a respectable looking probability histogram, I'm going to want to use the tidyverse family of functions, in particular the ggplot package. So I'm going to load those functions up using library parenthesis tidyverse. If you don't already have the ggplot package and the rest of the tidyverse installed on your machine, you'll first need to do install.packages parenthesis quote tidyverse in order for this command to work. And of course, you'll have to be connected to the internet in order for that to work. The quickest way to do a probability histogram is going to be with the qplot function. So let's jump in with that. We want the x values on the horizontal axis, and we want them all to be weighted, W-E-I-G-H-T, according to those probabilities. Let's specify that we want a histogram, although that is technically redundant. Let's see what we get here. So this isn't quite going to be right. Again, there are 6 possible values. Here R is using 30 bins by default. So let's go back and change that. We'll just go down to 6 bins. And also let me add a little bit of boundary here so that we can actually tell these bars apart. So we'll make some black outlines on these dark gray bars. And that's a respectable looking probability histogram for this particular hypergeometric distribution. Okay, so let's get back to this last question. Simulate the composition of 50 such teams. This is going to be an R hyper command. We want to randomly generate 50 random values from this same hypergeometric distribution. So R hyper parenthesis 50, comma 19, comma 11, comma 5. And there's our 50 values.